Welcome to the Stormsurf video surf forecast for the week starting Sunday, June 2nd. Looking at significant wave heights for the South Pacific Ocean, we see sort of a gale developing, but in the far southeast Pacific, for the most part, out of the southern, even the southern California swell window. So doing nothing for our forecast area, but doing something probably for Peru and Chile. And also tiny bits of seas, what is that, 23-foot seas off the northern tip of New Zealand. Probably doing nothing for us as well. Maybe swell for Tahiti, but probably nothing even up into Hawaii. And that's the picture for the moment. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales when they do form, helps direct their track. We're looking for a trough, that is a push in the jet stream, just like that right there, to the north. And that helps create actually a clockwise flow aloft in the southern hemisphere and down at the ocean surface. That's the hallmark of low pressure in the southern hemisphere. It is counterclockwise in the northern hemisphere. And of course, low pressure generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, they get smaller, but they turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a little trough here, and we know that there is some wind there because we know there's 23-foot seas right in that area, but that's not very much and pretty inconsequential. You can see the winds pushing up into the trough. This is really the part that matters right here. Are very weak. What is that, like 60 knots? You really need about 110 knot minimum winds to get something good going. And you see then over the central Pacific here, we have a ridge. That is, the winds push to the south. That creates a kind of a counterclockwise flow and high pressure in the atmosphere, and that's no good for generating surf of any magnitude. Then we have another trough here in the far southeast Pacific. It's apex right about there. So what's that, about 105 west? That's outside of the southern California swell window. San Diego's like, what, 116, 117 west, something like that. So too far to the east. Good for Peru, good for Chile, not so good for us. All right, let's put this into motion. So anyway, this jet stream flow, you can kind of get a sense of what's going on in the upper atmosphere, and then that sort of gives you an idea what support there is for gale formation in lower levels of the atmosphere. So as we go into Monday, you see the trough completely disappears here. The ridge pushes off to the east and pushes that trough off to the east, even further out of our swell window. Then you just have this, look at that, a new kind of a ridge building south here into Tuesday night and Wednesday. Just doesn't look good. Get the sense something maybe is trying to go on here under New Zealand starting about Thursday or so. Hard to tell, though. There's still that really hard push, southward pushing flow. But then, lo and behold, that breaks off and we get this rather broad-looking trough theoretically starting to form on Friday evening, looking a little bit better with, what's that, 140 knot winds feeding it into Saturday, and that continues. It kind of gets undercut as we get into Saturday night, and just doesn't look as clear. You really want it, it's kind of like a dirty trough. There's a bunch of junk running south of it. You really don't want that. You want it clean and open, sort of more like that there, but that's, again, too far east to be of concern for our forecast area. So maybe one trough of interest for the coming week per the upper level charts. All right, let's go take a look down at the surface. All right, here we are. Surface level wind, surface level pressure, and as expected, boom, there's a gale. Sure enough, 45 knot winds. Two patches of it, really. It's sort of a complex gale. One center there, kind of a center there. And when you get that sort of multi-centers all rotating around each other, they call that a complex gale. So that's what it is. But again, of no concern for us. South America, yeah, they'd be interested. Here's a more traditional gale. Small area, 40 knot winds. We know it's generating 23-foot seas pushing north, but again, probably not of any real interest. As we get into Monday, complex gale, still looking pretty good, but nothing for us, and everything else kind of just falling apart. There's high pressure. Remember that split in the jet stream? South winds at 30 to 35 knots, going the exact opposite direction of what we want. We want wind pushing to the north. Don't have it. So we continue on here, just looking for anything that might generate something. So Tasman Sea, 45 knot winds, somewhat aimed at Fiji's, maybe something to keep an eye on there. And then another system, here's the thing we're more interested in as we get into Thursday, 50-knot winds, 45 to 50-knot winds, pushing east. But if you actually saw the Great Circle tracks, they kind of go pretty much like that. So that's actually pushing towards California, if you can believe it or not. Anyway, Thursday night, Friday, then even more so, 45-knot winds, good long distance away, and hard to believe it's actually going to form actually another little gale right here in the central South Pacific too, and another in the southeast Pacific. So some hope if one is going to believe models 130 hours out or so. Broad fetch of 30, 35-knot winds as we get into Saturday, and then that, actually redevelops. I thought it was going to fade out. 45-knot winds as we get into Saturday night again. Looking pretty solid here. And another one pushing under New Zealand as we get into Sunday, 18Z. Oh, I see what the difference is. This is the 18Z run of the model. The previous models we've been looking at are all 12Z runs. So the new data is just updating here. Okay, so this actually looks, according to this, 2 decent systems forecast under New Zealand. Now, my guess is we go look at the wave models and everything else, they're going to still be the 12Z. They're going to show the not so optimistic view of the world. But remember, this is 180 hours out, so none of this is really believable. But it gives you a sense of how much difference there is from one run of the model to the next. Over 6 hours, when you're looking 5-6 days out, things can change dramatically. All right, let's go take a look. But before we do that, we're going back in time. We're going almost to a week ago, Saturday night. Here we are. There was a small gale that developed in the south central Pacific with, what was that, 28? And there's a little patch there. Oops, we'll pull this up just a little bit so you can see it. There you go. 31-foot seas in that one spot. Okay, this swell, this system has actually produced swell. Swell is in the water. It's starting to tickle the buoys just barely in California. It's pretty much too east. I mean, Hawaii is at like 158, so all this energy is east of Hawaii. So no real swell has resulted from that relative to Hawaii. Then on Sunday day, fetch built again. Little area of, what was that, 30, looks like about 34-foot seas building to 39-foot seas over a tiny area, but there'll be swell from it. And pushing to the northeast, that's good. As we got into Monday, seas still held, 38-foot range, and then it started to fade out. And after that, well, you just see, we'll roll this out. This Tuesday, Wednesday of last week, and really nothing happened, and that gets us to where we are today. All right, let's go take a look at the forecast. All right, so we're looking for, well, of course, the system in the southeast Pacific. We're not going to focus on that. Little tiny area, 26-foot seas on Monday. Good for Tahiti, but that's probably about it. Small swell there. It's not till we get till later in the week. Now notice this. Relative to Fiji, not bad. It'd be great if it pushed up into the Tasman Sea, but instead it basically goes and slams right into New Zealand, but it gets a little bit of northeast push to it. So one can expect swell for Fiji, certainly. And then it is this system here, Thursday night, getting into Friday, 40-foot seas pushing under New Zealand, and then continuing, actually holding 40 feet into almost Saturday morning. That's a week from now, then lifting northeast. And now remember, per the models, another system was developing down here. This wave model, the 12Z run, wasn't even aware that it was there. In the 6 hours later, the GFS model suggests another system with, 45, 50-knot winds pushing under New Zealand. So potentially 1 and 2 swells a week from now being generated if one is going to believe the fantasy of the models. Otherwise, let's go take a look at wind swell production. Okay, typical summertime pattern. Here's high pressure, 1026 millibar high, sitting right in the middle of the Gulf of Alaska. A little bit of a low. Last remnants of winter or spring or whatever you want to call it. Low pressure pushing through the Gulf of Alaska, probably making its way into Canada. We'll see here in a minute. But high pressure continuing along the California coast. And low pressure, heat low inland, that creates a gradient. That is the difference in pressure from low pressure to high pressure. And the closer the two systems get, the tighter the isobars get, those little blue lines there. And that creates wind, and wind, of course, creates wind swell. So Sunday evening, that's about right now. We have 20-knot north winds off of Cape Mendocino per this model, generating, waist-high, dribbly wind swell into, the San Francisco Bay Area. We also have a little bit of fetch trying to push into Hawaii, but east winds 15 knots. That's not, 15 knots will get you some, 8-second period wind swell, but pretty junky wind swell. If we get into Monday, okay, here we go. Winds build a little bit off Cape Mendocino, 25 knots, maybe a little bit of building wind swell, but notice it's all there. Then you have that sort of eddy flow. It doesn't show it here. It's showing northwest winds, but the reality is, with the fetch being this far off the coast, the wind will probably be south here along the, Central California and portions of North California coast. It's almost like a low here driving south winds along the coast. So if you can get out of the south winds, you get north wind swell. It's not a bad situation. And wind swell for Hawaii, pretty junky, small fetch area, nothing too impressive. We get into Tuesday, looks like the same thing relative to California, only the wind is moving closer to the coast, but still maybe an eddy flow. But for sure, by Wednesday, it looks like maybe not. Fetch for Hawaii, no wind swell. So just this continued wind swell thing, maybe building, but notice the wind building along the Central California coast into Thursday, 20-plus knots. And high pressure, look at this, getting much more organized now. The gradient building. There's your low pressure, there's your high pressure, 25, 30-knot winds. That's just junk wind swell for California for sure. And look at this, fetch off the south, so high pressure in the northern hemisphere, clockwise flow, that's how it works. Building fetch, pushing to Hawaii, but only getting to within about 500 nautical miles. Maybe some wind swell will result. That's a pretty good-sized fetch area. That's a couple thousand, 1,500, 2,000 miles of fetch aimed at Hawaii. Only 15 knots, but that'll generate wind swell. Okay, and of course, junky wind swell for California. Oh, winds building to 30 knots Friday night into Saturday. More junky wind swell. Fetch dies relative to Hawaii. And then we get ourselves into Sunday. The gradient starts lifting north, pulling away from the coast. Yes, you still get wind swell down here. Eddy flow likely as we get into next weekend for California. No wind swell for Hawaii. So, plenty of wind swell. Standard pattern, really, for this time of year. It's good to at least have the wind swell, because if you didn't have southern hemiswell, then you'd have nothing at all. Take what you can get. And now let's go take a look long term. What's going out beyond a week? We normally talk about snow, but there's no snow. It's summertime now. Snow levels, I'll just do it real short. Not a drop of rain forecast in terms of cold front rain. Yes, summertime showers in the Sierra for sure. But snow levels, all 12,000 feet or above, 13,000 feet. So snow's over. The big melt will likely begin as temperatures start to rise. All right, as usual, we like to start this portion of the tour off looking for the presence of the Madden-Julian Oscillation, the active phase in particular. So the MJO is this weather pattern that runs along the equator from west to east. When in the active state over the Pacific Ocean, specifically the West Pacific Ocean, it basically is like a big low-pressure system, but very generic. And it can turn trade winds, basically cause them to reverse, and that imparts energy to the jet stream, and that in turn can help to generate storms or weather either in the northern hemisphere or in the southern hemisphere. So in the southern hemisphere in summer months up here, and in winter months, it helps definitely support the storm formation in the Gulf of Alaska and out in the Dateline region. Right now, we're looking at winds. This is from the TAO buoy array, a series of buoys strung across the equator. That's New Guinea there. That is the equator. So this would be the far east Pacific. This is the west Pacific here. The dateline is right there. The arrows tell you wind direction. The bigger the arrow, the harder the wind. So pretty firm out of the east over the whole way to the dateline, then pretty weak. And specifically, we're interested in this area from 5 degrees north to 5 degrees south, from 135 east to 170 west. When you get west winds or west anomalies in there, then that can help create a thing called a Kelvin wave. And if you get basically west winds take warm water. You can see the temperatures here. These are the warm temperatures in the West Pacific. If you have east winds blowing all the time, they take warm water from the East Pacific, push it to the West Pacific, it all balls up here. And then if you all of a sudden get a burst of westerly winds for a couple of weeks in this area, they'll take that warm water, start pushing it back to the east, but not on the surface, at depth, down about 150 meters, and that is what is known as a Kelvin wave. If you get multiple active phases of the MJO in close succession to each other, then you get multiple Kelvin waves, and if you get enough of them and they're strong enough and there's enough velocity to it, it'll start those Kelvin waves will start erupting over off of South America, Ecuador in particular, and the Galapagos, create a warm pool there, and that is the hallmark of El Nino. All right, so right now we are in kind of we'll call it a minimal El Nino. We've been in the active phase of the MJO for a month now. We are expecting the MJO to fade. And looking at this, well, it still kind of looks, well, let's go down here. Anomalies, differences from normal for this time of year. Yeah, the arrows are saying, not neither east nor west here, but it's in the Kelvin wave generation area. Again, right in here. What do we see? Arrows coming from the west. Westerly anomalies. So, some version of the active phase of the MJO still looks like it might be in play. But remember, this is 5-day average, so the winds could have died, and these arrows will still hang around for a couple of days. Let's drill deeper. All right, so here's a different kind of chart, and this is the forecast for the week out. It's basically the GFS model. Zonal wind anomalies right there. So what's that mean? It means the east-west component of the winds, because that's all we care about. Is it stronger are the trades stronger than normal or weaker than normal? If they're stronger than normal, that sort of says it sort of says the inactive phase, the MJO. If they're weaker than normal or westerly, that says the active phase, the MJO. So these reds mean the westerly anomalies, okay? And how do you read the chart? Well, there's the date line right there. This is the whole planet on one chart. So the Pacific is like 135 east to about 90 west, so there. But the Kelvin wave generation area is from about here to about here. So you can just go up this chart, and there's the dates. So you can see all of May we had westerly anomalies. Good way to create a Kelvin wave. We're looking for that right now. But that Kelvin wave, and it was driven by the active phase of the MJO. The MJO runs about 4 weeks active, 4 weeks inactive. Textbook case right here. Active phase of the MJO, pretty solid one. Westerly anomalies can create a Kelvin wave. All that looks good. But where are we now? Well, about the end of May, the 28th of May, 29th, it looked like the westerly anomalies died. Easterly anomalies, the blues, are building. Textbook case of the inactive phase of the MJO. Not good for Kelvin wave production. And because we have a solid active and then a solid inactive, so when you put it this way, when you have El Nino, you tend to not get easterly anomalies. It's like a long-running active phase of the MJO where you get westerly anomalies. Then they kind of die off for a couple of weeks during the inactive phase of the MJO. Then they fire up again. But because we now have westerly anomalies going to easterly anomalies, sort of suggests that El Nino is dead or dying, or we're moving more into what would be considered a normal pattern, not an El Nino pattern. We'll dig more into that also in a minute. So back to the MJO. What's going on with the MJO? Okay, so this is outgoing long wave radiation model, a 2-week model. We're going out 2 weeks. Okay, when you see so these are not wind anomalies. These reds and oranges on this chart mean sunlight reflectivity off the ocean surface. Okay, and remember we said the MJO is sort of like low pressure and high pressure. If you have a lot of sunlight reflecting off the ocean surface, like we have here, that means probably high pressure means no clouds, whereas all the clouds appears to be in the Indian Ocean. So one could say the active phase of the MJO is in the Indian Ocean, right? There's India, and then Philippines, New Guinea, date line right there. Inactive phase of the MJO in the West Pacific in the Kelvin wave generation area at day 0 and at day 5. But then breaking apart this is a statistic model at between days 6 and 10. And according to this, by 2 weeks from now, the active phase of the MJO should move from the Indian Ocean over the maritime continent, start to seep into the West Pacific. That would mean support for storm development in the southern hemisphere could theoretically improve. But this is just one model. there's also the GEFS model, dynamic model. It starts out the same, saying basically the same story with the inactive phase dying, and it has the active phase moving into the West Pacific, but not as strong. See, look at the difference. There's 1, there's 2. But again, you're looking at models that are going 2 weeks out, and of course there's going to be a difference. I don't believe a model more than about 5 days out, but it gives you some clues as what to look for. So basically, the suggestion is for about the next week and a half or so to 2 weeks, probably not a whole lot of support for storm development. Knowing this and then thinking back to what we were looking at earlier where, oh, there's supposed to be 2 storms coming under New Zealand. Well, it could happen. It doesn't mean that you don't get storms happening during the inactive phase of the MJO, but there's not super good support according to these models for that happening in the next week. Phase diagram charts, another way of looking at the MJO. So you go, what is this thing? Okay, see that circle? Just assume you're looking down on the North Pole, right there in the center. Okay, and the equator runs around the outside, and the MJO runs on the equator from west to east, from the Indian Ocean over the Maritime Continent, across the West Pacific, underneath the United States, across the Atlantic, over North Africa, back to the Indian Ocean. It goes round and round, and I don't know how long it takes. Quite a while. Month and a half, 2 months, something like that. Anyway, the heavy dot is where the active phase is right now, in the Indian Ocean. No big surprise. The further away it is from this circle, the stronger it is. So, pretty strong, moderately strong. Active phase of the MJO in the Indian Ocean. This is statistic model, and the forecast has it making it to the Maritime Continent 2 weeks out from now. The dynamic model starts out the same and basically gives some variation on the same thing, saying 2 weeks from now, active phase in the Maritime Continent. Not in the West Pacific, but in the Maritime Continent. So, something to consider. And now here's an upper level model. This is like jet stream level. Same sort of deal, only this is showing potential for precipitation. The reds saying sort of like high pressure, inactive phase of the MJO. Greens, active phase, the area is favorable for precipitation. So inactive phase, and this runs about a week ahead of what's actually going on down at the surface. So inactive phase, working its way into Central America, June 12th, throw another 7, June 20th, let's say. That's the inactive phase. Active phase, pushing its way into the West Pacific, about the same time, let's say June 20th, and then making its way across the Pacific, and then further out, another inactive phase, July 2nd, so let's say July 9th or something like that, and making its way across the Pacific. So you can sort of see where the big fat window is for storm development. It would be right in this time period. If you're looking to plan a trip or do something in the Pacific, that would be the time to do it. And yet another model. Okay, this is one of these charts again, whole planet on one chart. Kelvin wave generation area between about here and here. The Pacific between about here and here. But this is actually showing westerly wind anomalies, okay? And you can see in the past, here was a little bit of a westerly wind burst back in March and April. And there's your inactive phase of the MJO. Yeah, well, supposedly a little bit of easterly anomalies. Then here was our big active phase that went from basically the whole way through May, and it is ending now. The dotted contour is our inactive phase right now. The blues are easterly anomalies. You can see that, and that's supposed to go that's a week, 2 weeks, about a week and a half. That's not bad. And then after that, as we get into 10th of June or so, westerly anomalies again set up over the Kelvin wave generation area, and then we should be back in business. And the final model, this goes out 3 months. Same sort of deal. Kelvin wave generation area between right about in here, but the dates are reversed here. This is back in the past. This is February. Westerly wind burst there. Then here's our most recent westerly wind burst. Not as strong as the one in February, as you can see. Then here's the forecast going forward. Here we'll overlay the MJ. And what you can see real quick is gentle west anomalies, but slowly fading over time. We'll overlay the MJO. Here was our most recent active phase of the MJO fading out. Here's the current inactive phase that we're in right now. We're not even at the peak of it, another couple of days. And then as we get about halfway into it, notice westerly anomalies start building again. And here comes the active phase of the MJO. Not particularly strong, but not weak either, just a moderate one, starting sometime in late June and then continuing into August, and then inactive phase the MJO after that. So you can sort of see the setup for this summer. Also, let's overlay the low pass filter. So this gives you the El Nino, the even longer term look. So these black lines here, right here, this is sort of like a low pressure bias. It was pretty strong here back in March and April, but it was even stronger back last year. But you see, we go from 3 contours. We're currently at 2 contours today, and that second contour is supposed to fade out at the end of June. So what that means is stronger potential for El Nino, getting weaker, and then all this looks like it's about to die sometime in August. And now that doesn't mean you're going to La Nina, but notice this here. The low pressure bias moves. This is the Indian Ocean over here, and it was dominated by high pressure. But as we get into August, this model suggests low pressure moving into the Indian Ocean. That might mean high pressure by later this winter building into and over the dateline region. Now the question is, does that mean La Nina for the Pacific? Maybe, maybe not. Too early to know, but you sort of see the setup and see the trend. Whatever El Nino we're in, this model is strongly suggesting that it's going to get continually weaker and die out and move out of the Pacific at some point. All right, let's go take a look and see what effect the westerly wind bursts and all these westerly wind bursts that we've been having the past year are having on the ocean, but not at the surface, down at depth. We're looking for Kelvin waves. This is the West Pacific here. This is the East Pacific here. These are the anchor lines on the TA buoy array strung across the equator. The X's are the little sensors on those anchor lines. If there's an X there, that means it's operational. If you have a gap, like maybe there, or maybe there or there, that means some of the sensors are not operating. See, like that one there. Let's assume there's ones the whole way across here, but they're not operating. Anyway, you get the deal. Okay, so reds, 30-degree centigrade temperatures. This is actually building significantly even in the past 2 days, suggesting warm water is building into the West Pacific. Why would that be? Well, we've had a whole month of westerly anomalies in the West Pacific, so maybe we're getting Kelvin wave number 4 of this series. The 29-degree isotherm line holding at 155. That's about where it's been. 28-degree isotherm, it was the whole way into Ecuador at one point, maybe a month or so ago, but it's creeping back, but still about 136. That's where it's been. And then the 24-degree isotherm line still pushing the whole way into Ecuador. That's a good sign. It's still suggesting that we're certainly not anywhere near La Nina. We have warm water here, but this is the most interesting development just in the past day or two. All right, let's go take a look at anomalies, differences from normal for this time of year. All right, so the typical scenarios, you have cool water in the east, warm water in the west. If you have a whole bunch of cool water, that's La Nina. If you have less cool water, that's El Nino. Clearly, we're in some sort of El Nino. We have 1 degree above normal. There's negatives. We don't have that. We have above normal temperatures whole way across the Pacific with this is actually building pocket of 2-degree anomalies off of Ecuador. And it almost looks, it's hard to say what's going on here, whether these are warmer than normal for this time of year or not, but it doesn't look like it according to the anomaly chart. This is just normal temperatures. Let's go take a look at another chart. So here's another model of the same data, just a different source, and here's our big warm pool, a whole way over to like 150 east. So basically the entire equatorial Pacific is full of warm water, and it'll take 3 months or more for that to discharge. So what are we? We're at June, July, and August will still be warm water upwelling, but at some point, if we don't get another Kelvin wave, then that'll be the end of it. Notice this little pocket of cool water here. This might be the upwelling phase of the Kelvin wave cycle. Between successive Kelvin waves, sometimes you get a little poke of cool water popping up in the East Pacific. Upper ocean heat anomalies. All right, so this is a way you can kind of visualize Kelvin waves. Back July of last year, that was Kelvin wave number 1. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 2 by another strong westerly wind burst over here in the West Pacific is the East Pacific over here. You see warm water moving its way across the Pacific, moving into Ecuador. Upwelling phase of the Kelvin wave cycle. Kelvin wave number 3 and it pushing through. Here's the upwelling phase of the Kelvin wave cycle. Now here's another little bit of data that's encouraging. See, notice the warming building here. So maybe this is Kelvin wave number 4. Probably not a very strong one because notice back here there was a lot of warm water in the West Pacific. Now there's hardly anything. So you get this last little push, that'll pretty much tap the system out. There is almost no way you're going to get another Kelvin wave after that. And that probably signals the end of the El Nino cycle. And then as we get into later in the winter, we might be moving either into a neutral pattern or a La Nina pattern. Again, way too early to know. We are in the spring unpredictability barrier. This time from March to about June. Yeah, right about now. We're just about out of that barrier, actually. So we'll know. The models have a hard time. Let's say in the next 2 weeks, we'll have a much better sense of what's going to go on long term. All right, what's going on the ocean surface? If you've been following this, you've noticed the past week there's this big area. The reds are above normal temperatures. You can see this scale over here. This is anomalies, differences from normal for this time of year. We had a good amount of warming over here. It's still pretty warm. There's the Galapagos. There's Ecuador. There's the equator. You get the idea. This is the Nino 1.2 region right in here off of Peru, right in this area. It's noisy. You can get bursts of warm water, but they have to be prolonged. They have to get caught by the trades blowing out of the east. The official El Nino monitoring region, 120 west over to 170 west, 5 degrees north and south of the equator. You see, that's pretty warm. So there's this warming will eventually work its way over, advect over into the Nino 3.4 region. So nothing suggesting a significant cooling taking place, but nothing suggesting solid El Nino either. You'd want to see a lot warmer water over a broader, more defined area in this. This looks like a weak El Nino at best. The trend for the past 7 days, you can see this cooling actually, if anything, and we were saying it earlier, it looks like it's cooling in this area, not as warm as it was, but that doesn't mean that it's cold or anything. It's still above normal temperatures, but just cooling in pockets in this area. But there is no significant warming really anywhere here in the Pacific on the equator. That's what matters. Not up here, not over here. That's all kind of noise area. It's right in the equator that's all the action where things really matter. And we don't see any signs of a warming pattern of any magnitude. And here's the backed off view. Okay, you can see all the oceans are warmer than normal. We're not going to wade into that end of the pond, but that is a reality, is the oceans are getting steadily warmer. We're talking, quarter of a degree makes a difference. The difference between El Nino and not El Nino is a half degree. If you're normal, it's 0. A half degree above normal for 5 consecutive months defines El Nino. So it doesn't take much to upset the balance of the atmosphere. Small amounts of heat can make large differences. Anyway, but in the official, so this is the Nino 1.2 region right in here. Looks warmer than normal, and we know that to be true. And then the Nino 3.4 region out in here, yeah, that looks to be normal. This looks like a very, very weak El Nino pattern. If it was strong, you'd see basically reds all in this triangle area here. We're nowhere near that. This is mild at best. Actual temperatures, Nino 1.2 region, right there up against Peru, Ecuador. Today's value, minus 0.492, so half a degree below normal. You can see the trend. It got hot for a week, cold for a week. I mean, it's just been bouncing all over the place. Very noisy, but if you just, in your mind's eye, try to go, well, what's the average going on here? It's right about dead neutral. The Nino 3.4 region, the official El Nino monitoring region, more steady, if you will. Today's value, about 3/4 degree above normal, 0.776. Okay, but the trend line, you can see it. It's been sort of heading down. Yeah, we get these couple little upbursts, but my guess is this is going to continue a slow fall downward. All right, what effect are these temperatures having on the atmosphere above the ocean? One way of measuring that is the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. When the difference or the index is negative, for over short runs, it doesn't mean a whole lot. Over 30 days, it means the active phase of the MJO. And today we're at minus 2.46. That's not much. You want to get down around minus 20 or so. But you can see for the past week, yeah, it's actually been, I don't know how many days this is, but 2 weeks worth probably. We've been pretty negative. Active phase of the MJO. So, and you can see even back, well, the whole month of May was basically the active phase, westerly wind burst. You can see that pretty clearly on the index here. The average, 30-day average, down to minus 8.66, and we'll just sort of scan down here. Yep, it's been, the index has been dropping. You want it to be negative. The more negative, the better in terms of storm production and energy input into the jet stream in the Pacific. The 90-day average, though, it sort of takes the peaks and the valleys and everything out. Minus 5.63. That's not El Nino. I mean, real El Nino starts at about minus 10 or 12 and stays there. We're at minus 5.63, and we've been, we're at minus 7.5 or something, So it's slowly kind of working its way up, but not really going anywhere for the moment. This puts things in perspective. The 30-day average charted out over a couple of years. So here's where we are today. This says minus about nearly 10, but we know we're about minus 8, something like that. But you can see we're actually, so these upward spikes are the inactive phase of the MJO. There's the active phase, inactive, active. This was, and you kind of get, you can just sort of watch the trend. If anything, it's actually been heading downwards still, suggesting that maybe El Nino isn't over, or we're close to the peak of it, if anything else. And we've been holding in this, well, let's see, this is 2017, so this was La Nina when we were positive, minus 12, kind of in that. And then in 2018, we started falling, kind of lost it in January. Now we're falling again. Don't know where we're going to go, but again, El Nino, real El Nino is down around minus 15 or so. We're not there. We're not going there. We haven't been there. Probably isn't going to happen either. And then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. So here's where we are today. This says we're at about 3/4 of a degree above normal. That seems a little bit optimistic. But you can just look at the trend. These are all the different, they run this thing every day or multiple times a day, so you see the spread. But the average, when you draw the line through it, says, okay, we're hanging somewhere around, there's supposed to be some decline that's supposed to go on pretty solidly, lose 1/4 of a degree in July, and we pretty much, by that time, we're not in El Nino territory. You got to be 1/2 degree or more, right? As we get in July, we fade below that. Into October, 0.3 degree. Hanging into about December. We get into January, we're still 1/10 of a degree above normal, but basically, we return to normal. So El Nino fading out as we get through the summer and into the fall. Still, the deal is the atmosphere, it takes a while to respond to water temperature changes. The water doesn't go normal and, that's the end of El Nino. It takes like 3 months. So my guess is, as we get into the fall, the atmosphere will still sort of act like a weak El Nino. And even as we get into December, weak El Nino, and it probably won't be until January, February that we'll really see what's going to happen here. And as the atmosphere loses momentum, we'll see whether we fall down here into La Nina, or whether we actually hold just kind of around neutral. Will be interesting to see. But for now, one last southern hemi swell, guaranteed, on the way. Nothing huge, but small swell, mainly for California, and next to nothing for Hawaii, because most of it's more in the southeast Pacific than the central and west Pacific, the storm was. So, small swell for the bulk of the work week, nothing huge, but rideable, and then building wind swell later in the work week into next weekend. And by then, we'll be able to see whether there's 2 systems forecast pushing under New Zealand, Friday, Saturday of this coming week. We'll see whether that materializes or not. Hard to say, a little bit early, but something to hopefully look forward to. In the meantime, though, the inactive phase of the MJO is supposed to be setting up the next 2 weeks in June, so probably less surf is the expectation, and high pressure building in the Gulf of Alaska. That means wind swell is probably going to be the best shot for first 2 to 3 weeks in June, unless we get lucky down south. And then long term, El Nino, the expectation is that's going to be fading out, and we'll just be into more of a normal kind of pattern as we get deep into the winter later this year. So that's it for this week. We'll do it again next week, same time, same channel. Thanks for watching.